Thank you, Marco. Well, there is a reason. It's amazing that hundreds and thousands of aircrafts are flying in the air and they land safely. So I find that to be amazing. You know, I spent 11 years in a company, telematics, making hardware and firmware, and I swore I would never touch hardware again, right? Today, my topic is boring. I'm talking about Agile. I'm talking about ignorance as the other side of the coin of knowledge. And I'm trying to answer the question why Agile matters. I mentioned earlier that when I was a client of Arkus, initially, Arkus offered this model, the Scrum teams, like, this is what you need, you will be successful. I was like, no, I don't. I just need 3 developers to do my stuff. And they were able to convince me that it's a good idea. And over the following 6 years that I was a client of Arkus, I truly enjoyed that model. I joined recently, less than a year ago, Arkus as a CEO. And one of the biggest questions that truly define how we do business and how we collaborate with clients is this fundamental question: why is Agile so important to you guys? And I'm going to try to answer that question here. So when we think of software, we think of success, we think of improvements, we think of productivity, we think of savings. Until we actually crash and burn, we don't think of failures, we don't think of wasted resources and opportunities. And that failure is very expensive. Some people try to quantify it. There's a lot of data out there, a lot of research out there, trying to put some figures on it. And my first question to Google, then to ChatGPT, is how much do we waste every year on bad software implementations? And I was shocked by the number. It's up to $75 billion every year just in the US alone, because so many reasons wasted because software implementations did not go as planned. The other funny thing, 75% of IT executives of those failed projects said that those projects were doomed from the start. And this is according to Oxford University. That's a high number. What do we do about it? 20% of the cost of the budget goes to rework, fixing problems that should have never happened to start with. And if I put a focus and I just grab the magnifier of the Project Management Institute, they estimate that 11% of the project that failed did so because of poor methodology or poor project management practices. Chris is nodding. I feel much better about that. Thank you. I'm going to compare Agile methodologies to waterfall methodologies. And waterfall, we should give it credit. It did a lot of good work. It serves a purpose, which I'm going to cover later. But if I compare both, how do they stack against each other? And I'm going to talk about tiers of projects, the ones that just succeeded, no problems, they just worked, right? At that level, only 13% of the projects that succeeded followed waterfall versus 42% of Agile projects. When I moved to the next tier and talked about the projects that expressed challenges, the numbers are scarier. Almost 60% of the waterfall projects had some challenges. On the Agile side, it fares better. I mean, it still can do better, but we're talking about 47%. The last tier, and no one wants to be in that tier, is the failed projects. 28% of projects that failed were a waterfall methodology versus almost 10%. And if I have to stop this presentation and have you remember only one slide, it's going to be this one, comparing both, summarizing the data. When you adopt a waterfall, you are twice more likely to fail. And when you adopt Agile, you are 3 times more to succeed. Thank you for your attention. No. Yes. I wish it was that easy. So I'd like to borrow some examples from my own life, right? I've been writing bad software since 1993, right? This is why I realized my own software is not that good. I would just manage people write software. It's easy to tell people what to do than to actually do it. Here is an example. Back in 2010, the DoD gave my company a project, a binder. It's like, we want an application. I can't talk about details. It's classified. But here is the binder, just read the binder, and you have 6 months to write an app. And at that time, we're a small company, and we're an extreme programming team. The developers amongst you know exactly what it is. You're doing everything but looking at a binder with specs. And we started working. We're so excited. Part of it because of the prestige of the client, but part of it because it was a cool technology. Back then, mobile devices were not readily available, so it was really cool stuff. Then we got to a point where we needed to test. We needed more info. The prototypes we built needed to be validated by users in the field, aka military people. And that's when we hit a wall. And when we pick up the phone, it's like, we need to coordinate some testing. The answer from one of the officers was like, what do you mean tested? What do you mean you don't know what you're building? What do you mean you need to validate your application? And I did not realize it that actually they were following the classic waterfall methodology. The framework is we define the requirements, you design, you architect, you code, you deliver, we're good, we shake hands, thank you for your business. But that's not how it works in real life, at least in our level. And it's very difficult to argue with the US Navy when you have a couple of officers, right? And literally one of them told me, is like, you're dealing with the team that built nuclear submarines. Failure is not an option, make it happen. And that's when I called my boss. Like, you got to explain to this guy, this is way above my pay grade. But it's definitely a collision of two methodologies, Agile colliding with waterfall, right? And in this case, the US Navy wins. We have to do it their way. Another example, while I mentioned I was doing hardware in the past, we grabbed your regular Garmin, and Garmin released what they call the fleet management interface, and you can actually build some nice software and push stuff to trucks. And we said, why don't you use that to push work orders from our interface? That's a very cost-effective way that will bring costs of implementation of hardware from $15,000 to $1,500. So there is definitely a need for that. We built it. We tested it in the lab. It worked very beautifully. We tested it on a customer site on a weekend. A few weeks later, we deployed it on a Monday morning. We're so excited. I remember 5 a.m., all excited, seeing those work orders leave the servers, right? And by 9 a.m. Central Time, we get this angry call from a dispatch, like, your system is a piece of crap. It doesn't work, right? Our vehicles are not getting anything. So we did some investigation to understand what was going on when we realized that we are limiting the number of orders we send to each truck to 300, if I remember. But the dispatchers are sending between 900 and 1,200 to each truck. It's good news, right? We know what's wrong, and we have to fix it. So I'm talking to the software engineer in charge of this, and he said, I know what the problem is. They're using the system wrong. They have to change the way they do business. It's like, do you have any concept? You can't tell waste management to change the way they do business. But had we adopted a more agile methodology and involved the client in defining the requirements and spent enough time to understand what it takes to actually make this kind of system work, we would have not embarrassed ourselves in the manner we did. Last example I'm putting in here, just love of aviation. We're all aware, we all remember the two crashes of the 737 ended up being the problem with, it's a software problem. Had Boeing actually taken that part seriously and designed some redundancy, I think more than 300 people would have been alive now. Software fails for so many reasons. This is not an exhaustive list. This is just a sample of why software fails. For human factors, technical factors, for so many reasons, your software is running risk at failing. Again, it's not meant to be an exhaustive list, but just the idea that it's complicated. So when we look at the Agile, yes, it fares well. It does better than waterfall, but it's still not 100%. The best we can do is 42%. In another 47% of cases, we're still going to be challenged. And that's why you need someone as involved as a product owner, as involved as a Scrum Master. You can't just let the process drive itself. You need to be involved from the get-go all the way till the end. This is a book that changed the way I understand failure. Philip Armour, I think he's one of the authors of the Agile Manifesto. This is a highly recommended book. I recommended it to someone from my team here, Jorge. The laws of software process. And there's an interesting statement, and I think all developers would agree that it's very easy to produce software. It's very difficult to produce software that works. Once we know exactly what we are building and why we're building it, straightforward. Coding is not the problem. And I think Reza will touch on that, right? And I learned from Reza, right? I attended one of his talks in LA, and he was talking about ChatGPT and what it can do. And I tried it, and I went to ChatGPT and said, challenged it. Give me code that does this. And I need Java code. Well, now give me the Visual Basic. And he does it. It's scary, right? And exciting. I say scary because we're in the business of writing code and getting paid for it. But it's also exciting. So we know software gets its meaning from the purpose and the environment and the users. It cannot exist without that purpose. The book makes this interesting statement that software is not a product. Stop thinking of software as a product. Software is a knowledge acquisition exercise. You are here to learn what the users need and want. And I compare that myself, this is my example, not the books, to a labyrinth when you're building the software. You need to know what is your starting point. If you have a problem, how do I even start solving this problem? What kind of framework I'm going to use? How would I structure the work? Where would I go next? What is the path actually from my starting point till the end, et cetera, et cetera, et cetera. And I think one of the biggest questions is, how much would it cost? Who should I involve? What kind of resources? How long it's going to take? All these questions, I mean, sometimes at the early stages of projects, especially for startups, it's like, oh, easy. In 3 months, I'm going to build this. Maximum 6 months, in a year. Literally, I heard this from a friend. It's like, in a year, I'll be making $60 million. And that's when I literally stopped talking to him about the whole thing. It's like, until we agree on that, I'm not proceeding. I'm not even going to take you seriously. This is a simplified version of that maze, so we can actually run some simulations. And I'm trying to find the starting point right there. I know where the maze starts, but I don't know where it ends, and I don't know what the path is. And basically, I'm trying to find my path, and there is a learning process. I keep progressing, right? And the red color, I'm not sure you can see red with so much lighting, but the red color indicates that basically this path is not taking me anywhere. And I try different paths, and ultimately I end up in green, and I find my way out of it, right? So while doing so, I learned a few things. There is some useful and correct knowledge that will help me build my solution. And there is some incorrect knowledge that the author in the book calls N-knowledge. That will not make it to the final solution. One thing that's critical here, all the way the red color, all the way look at the left bottom, that's what the book calls late discovery. And this is one of the fatal mistakes in a waterfall methodology. You can progress for weeks, months, and sometimes years, all the way till the end, and you realize that you made one of the worst assumptions you could have made in your life, and that can cost you dearly. It happened to me personally with one of my startups. I invested 5 years building a product. We used a framework, JavaScript framework. Back then, the whole mobile app development was new. And as we actually are going live, Apple just pulled the whole framework from the store and said, this cannot run on our store. 5 years gone, right? So remember, this is my Picasso, right? So you will see some nice drawing there. There are two types of knowledge. There's incorrect knowledge and correct knowledge. Both of them are useful. We cannot progress building software if we don't run into incorrect knowledge. There is no way to avoid it. This is why QA is important, because in theory, when you acquire good knowledge, you just go back to the crap you have included in your code and just hit delete, right? And you just take it out. But developers know that that's not how it works. That bad code will be there. You can refactor, you can dedicate team members to actually eliminate the code. It will be there. And this is why you need a strong testing team. Late discovery, as I mentioned it, and I will touch on this later, is fatal can be fatal in the waterfall. And the real value, I forgot to mention this one, the real value is the knowledge. The book actually explained this better than I'm trying to do it here. The question is, if software is not the product, then what is the product? And the product is the knowledge contained in the software. And this mental map, right? As developers, we all keep these mental maps. We all have these explanations of why certain snippets of code reside in our code, and only we know that. It doesn't matter how much documentation we embed. Only the guys who wrote that code will know exactly why a routine was written in a certain way. But knowledge is the product. And once you adopt this mentality and you understand this detail that when you're writing software, it's not about your interface, but it's about the process to understand why certain things are done the way they are done. Waterfall comes from the industrial age. You start with your requirements and you architect design code before you start testing and deploying. And the same way knowledge matters, ignorance matters as well. And this is an interesting concept. This is the second most important slide I think I have in my presentation. Looking at an iceberg, right? We all know this mythical iceberg, and there's only the visible part. There are different levels of knowledge and ignorance, actually. And the 0th level of ignorance is when you know all the facts. You see everything, you can build a system, you identify it, and based on that knowledge, you can build a system that actually the user can use. Once you start dropping the level of knowledge and increasing the level of ignorance, then you're talking about the first level of, order of ignorance, where you have no knowledge, but you do have questions and you know how to get those questions answered. I know, for example, tomorrow there is a trip to Mexico, but I don't know what we're eating for lunch and where, but I can ask someone. It's like, Marco, what are we having tomorrow for lunch? Just an example. It gets worse from there, right? When there is a lack of awareness that there are questions out there, there are aspects that I'm not even aware of. For example, climate change. I read one book that promotes one idea. I walk away thinking I know everything about climate change, whereas there are so many perspectives that I'm missing. And you can imagine, apply the same logic to software, and you can imagine the consequences of that. Beyond that, the third order of ignorance is when there is no process. I'm so entrenched, I'm so convinced that I know everything, I'm not even trying to look beyond my boundaries and just miss this complete reality that should be embedded in the production of my software. And that lack of process does not fare very well with methodologies like waterfall. There is another layer called the fourth order of ignorance, which is being completely unaware of the fact that there are orders of ignorance. But I think by the fact of showing you the slide, we took care of that. So waterfall does not fare very well. It can handle the 0th order of ignorance when the requirements are obvious, known, documented. Once you start going, you are facing questions, uncertainties, then the waterfall doesn't do very well. So instead of the linear progression, Agile provides this model, the spiral model of timeline, where you start, for example, with a proof of concept, then you evolve into an MVP, and after that, you start developing your iterations or new versions of your same product. As you're acquiring knowledge, you're testing, you're validating, you're progressing cautiously, avoiding any blunders there. So lessons learned, this is what Arkus learned over the years. I think Angel mentioned it. Initially, it took 10 years to really know what we are doing. So initially, Arkus was doing fixed bids for years. We just basically take project fixed bid, budget is fixed, scope is fixed, and towards the end of the project, there is a crazy amount of activity trying to actually meet deadline, because we know that scope is never fixed. Scope will change. Clients will change it, and you have no way to say no, but to comply. So fixed bid was very stressful, very expensive. Then we moved into a different model, which is staff augmentation. It's like, why don't we shift some of the risk and just provide people and let the client manage it? The risk did not decrease, and the engagement was not as high. And we had to change models, and that's when we came up with the pod model. that provides this structure and rigid, in a way, methodology to make sure that our clients are engaged and our team is engaged as well. This is a theoretical model on when to use Agile. When the technology is known and the requirements are stable, then it's safe to use waterfall. You can use either one. As the complexity starts increasing, and this is the area where Agile and Scrum specifically can be useful, is when the uncertainty increases on both sides, then it starts making sense to use Agile more than waterfall. And when the technology is completely unknown and the requirements are fully unstable, then I would say, God help you. I don't think Agile can help there. So comparing the two, methodologies, waterfall is very predictive. I think DuPont, the chemical company, it's one of the big companies, did a study back in the past, and they say whenever you have a predetermined process from a chemical standpoint, then there will be no explosions. But when you don't, you cannot predict how the elements will mix together, then there's a risk of explosion. And Jeff Sutherland, one of the Agile manifesto authors, gave this example just to highlight the point that when you know where you're heading, waterfall is safe. When you have uncertainty, then it's better to be more cautious and go for a more adaptive approach. So all the developers know about Agile. I'm not going to get into the mechanics of it, how Agile teams work, but basically you have Scrum Master, developers, product owner interfacing with stakeholders and clients. There are periodic reviews and there are daily stand-ups, and the idea is to basically keep making iterations until we have a product that the client is happy with. How do we structure this internally as a company? How do we build our teams? You heard us talk about the pod model. There's a product owner, there is a tech lead, and there's a QA on top of developers, right? So that's our pod. That's the minimum unit we offer you, right? We're not going to offer you half a person, 75% of a developer, but we'll offer you a pod. That way, there is ownership from your side, there is an ownership from our side. As the team grows, as your needs change and go up, we're going to drop another pod. And it's our job, as Ivan here, can see him, likes to call it, right there. It's the black box. It's our magic. It's our job to make this structure work. That's why Arkus is Arkus, because we know how to scale this thing. We started with a company, Drata. I'm not sure if we have any Drata people here, but we started with this model and we grow it now. We're talking about more than 100 people following the same structure. Drop in some comparative numbers on how Agile can increase capacity on a gradual basis and a consistent basis, versus if you go waterfall, you have to wait all the way until you start testing before you see your capacity or capability delivered. However, the green line I'm showing here is not the actual waterfall. It's the waterfall in theory. In practice, because you have uncovered so many incorrect facts or knowledge, then the actual line is way below it. Similarly, just comparative approaches in terms of system capability delivery, it's the same thing. Agile always comes to the top. We're building a model, mathematical model to actually confirm all these theories. But overall, to keep it simple, this is how the different methodologies stack up against each other. With that said, when it comes to our business, there are 3 pillars to actually producing software. We need that creative mind. We need people to be creative to find true problems to solutions. We need a lot of communication amongst the team members between our team and the clients. And we also need trust. Without trust, we cannot do anything. This is why we insist on the structure we offer, because that allows our team to trust the leaders, but also trust the client and trust that we're making progress in the right direction. And that's why Agile matters. Thank you.